Hi all, we just want to talk about some harder algebraic fractions questions. I'm going to do these all with dividing fractions because remember, dividing fractions we're going to do multiplying eventually. So with dividing fractions we do keep, change, flip. We keep the first fraction the same, we change the division sign to a multiplication sign, and we flip the second fraction. So if I do that in this case, I'm going to get 2x plus 6 divided by 3 times 12 divided by 3x plus 9. Okay, keep, change, flip. Don't write that underneath. I'm just writing that underneath to help you. Then what we do is we just follow a series of steps which will always work. We factorize. So we factorize numerators and denominators. Then we cancel. And then we multiply. And remember, when we multiply the numerators together and we multiply the denominators together. So let's factorize what's common between 2x plus 6. Well, 2 is common. 2 goes into 2x and 2 goes into 6. 2 goes into 6 3 times, so that makes that 2 bracket x plus 3 over 3. And you can check that really quick by going 2 times x is 2x, 2 times 3 is 6, which gives you 2x plus 6 as we require, times by 12 over, then what's common between 3 and 9? Well, 3 goes into 9, so 3 goes out the front, x plus 3. Okay, then we cancel. So what's common between those? Remember, we can cancel up and down, or we can cancel diagonally. It's all good. Any of those ways works. So let's do that. Let's cancel. If I cancel, I'm going to get rid of the x plus 3's first, and then I'm going to see if I can do something with the numbers. So I can't cancel that 3 and that 3. I get tricked. I can only cancel diagonally or up and down. So I'm going to cancel that 3 with that 12. 12 divided by 3 is 4. So there we go. I've cancelled as much as I can because 2 doesn't go into 3. So I've just got to see what's left over. Remember, when I'm multiplying fractions, I multiply the numerator together. So in this numerator, it's the 2 that's left, and the 4 is left in this numerator. So that 2 and that 4. So I'm going to go 2 times 4 over, well, the 3's gone, so it's really 1. And we're just left with 3 here, so it's 1 times 3. That gives me 8 over 3 is my final answer. Don't change that to a decimal. 8 over 3 is more accurate than what its decimal would be. Okay, let's do another one. This is a bit of a woozy, but we're going to do the same thing. First step, as always, we are going to do keep, change, flip because it's dividing. 6x cubed times x plus 2 over 3x, and then we're going to times that by x plus 2 squared times x take 2 over 3 bracket x take 2. Now if we look at that, to the start we might go, oh, we've got x plus 2 squareds and we can cancel those, but wait, you can't. You can't cancel the x plus 2 squareds because they're not below each other, up and above each other or on a diagonal. We can, however, cancel the x take 2's, so let's do that. Cancel the x take 2's. Now can we cancel anything else? Well, x cubed and x, yes. X is really x to the power of 1. X cubed is x to the power of 3. So if we wanted to expand that out, that'd be x times x over x. So we'd cancel one of those x's. So we'd get left with x times x, which is x squared. So yes, we can definitely simplify that. Cancel the x there. Cancel that 3 and make that a 2. Can we simplify anything else? Well, 6 and 3 is a factor of 6, isn't it? 3 goes into 6 2 times. So now we've got 2. That's not 2. Remember, that's actually 2x squared. So you might actually want to write that in different colours so you don't get confused. So that's 2x squared. So that's all we can cancel now. So we've got left with 2x squared, and then we're just going to multiply the numerator 2x squared times x plus 2. We're going to multiply that with the other numerator, which is x plus 2 squared. And then we're going to multiply the denominators together, which is just 1 times 3. Now, x plus 2 times x plus 2 squared is x plus 2 cubed. And 1 times 3 is 3. Alright, so there's that example. Now I'm just going to do this one exactly the same, but I'm just going to switch numerator and denominator of one of those up to the numerator. So it's not going to be exactly the same, it's going to be pretty close. Just to see what would we do if we had 6x cubed times x plus 2 over 3 divided by 3x divided by, x plus 2 squared bracket x take 2 over 3x take 2. So all I've done here is I've switched the numerator and denominator in the second fraction up here. Okay, so we're going to do the same thing first. We're going to change, flip, keep the first fraction, change to a multiplication sign, and flip the second. 3 bracket x take 2 over x plus 2 squared bracket x take 2. So we can cancel the x take 2's very easily, they're gone. We can cancel the 3's, they're gone. We just got to decide what we do with the x plus 2 and the x plus 2 squared. So it's really x plus 2. We could write that, even though they're diagonal, as x plus 2 divided by x plus 2 times x plus 2 plus x plus 2 squared. So obviously we get to cancel one of those. So we can cancel that and get rid of the squared. We just get left with x plus 2. So we get 6x cubed times nothing, which is just 6x cubed over x plus 2. That's our answer. Can we simplify that? No, we cannot. We can't cancel that and that, or bits of that with bits of that, because 6x cubed is divided by the whole of x plus 2, not just by the x. So you don't do a legal cancellation. Hope that helps with some harder algebraic division and multiplication of algebraic fractions.